Good afternoon. I will talk about OpenVG overview and applications. I'm CTO of Hwanyong Corporation. My company is developing OpenVG related product and applications. OpenVG is a 2D vector graphics API. It is in Khronos graphics API stack. Many people ask me, there is OpenGL 2.0, why we need OpenVG? Actually, I cannot say that, but the purpose of OpenVG is slightly different. I mean, it's more high quality and more precise control of curve and surface. And then it will be used for drawing vector font and various kinds of user interface. Mainly, the OpenVG is targeted to implement. Target application is the SVG player, especially SVG tiny profile and SVG basic profile is basic target application of OpenVG. And we're also trying to make to support the flashlight player and PDF viewer and PostScript renderer. And also we are trying to support Java standard like a JSL 226, SVG Tiny 1.1 binding, and JSL 287 is a SVG Tiny 1.2 version Java binding. And the important thing is JSL 271. JSL 271 is the new version of MIDP. So this MIDP3 has the mandatory function of graphics, immediate graphics functions that is based on OpenVG. If hardware has OpenVG function, then it will easily can implement MIDP3 mandatory features. This pipeline is ideal shape of the OpenVG pipeline. Each object should be passed this 8 stage of pipeline. And final stage, we should do anti-aliasing or blending function. It is same as OpenGL. OpenVG is a kind of giant state machine. We define state of the machine, and then we give the input data. And then we control some parameter of state machine, and we input that draw. Then the state machine generate output as an image. So that output image can be used as input image, or we can manipulate that image. But mainly the object drawing is the main purpose of OpenVG drawing. So then we look into more precise features of path over OpenVG feature. That we can define path with a straight line and WebGL and elliptical arc. And we can also calculate that the bounding box of a path or transform bounding box, or point along path, or tangent vector of a path. It is useful for drawing some various very sophisticated shape of a path, and we can calculate the path geometry for using very sophisticated drawing. Okay. And we can define also the stroking parameters. There are 3 kinds of handicap shape, the quad, round, and square. And we also have 3 kinds of joint style: bevel, round, and meter. Where is meter? I think something wrong in the PowerPoint drawing. And we also define the dashed line shape. And we can also do the transformation of path or image or font. But the perspective transform is only possible for image. And path and font, we can only do the affine transform only. And we also control the transformation of a paint. So there are two kind of paint, the stroke paint and fill paint. So totally we can control 5 kind of transformation. The two paint, the stroke paint and fill paint, and path transformation to screen, image transformation to screen, and font transformation to screen. By controlling over these 5 parameters, we can achieve various kind of painting effect. We also have a scissoring function that we can define which area is drawn, which area is not drawn. And we can also control which pixel is drawn or which pixel is not drawn, which pixel is half drawn by masking function. And we also control the masking image by the intersect, union, subtract command. In OpenVG, we can paint with solid color and linear gradient and radial gradient, and we can also do pattern filling. And we can control the repeat parameter of the gradient and pattern. Just repeat and reflect of a gradient. Or in case of pattern, we can do padding or repeat or reflect is possible. In case of image drawing mode, we can choose 3 kind of the drawing mode. The first thing is normal drawing. Second thing is multiply. Multiply can be used for in source image, in paint image. The paint image look like this, and we can multiply, and we can get the result of this. He is my son, when 1 year old. Now he is 17 years old, kind of monster. And I love that. 1 year old, yes, beautiful age. Okay, and also there is some kind of stencil, stencil painting mode. Stencil is passing some color to use the own blending mode. So it is very complex. So you can look into this slide, then you can predict the result. So we can define the image as what color will be passed to screen, and then it will be merged into background image. In case of a background is black, then we can achieve this result. In case of background is white, then we can achieve this. And in case of some images in background, then we can achieve this color. So to predict that stencil effect, you should see the equation of the blending equations and the stencil equations. So, and I will talk about later. And there is, even though it is a VG means the vector graphics, but there is also the bitmap graphics feature. So there is a very simple kind of image convolution and image filter function. So we can do the blurring, sharpening, and we can make edge detected image by simple image convolution function. So for example, this woman is my book designer, so she argued that I need my face in my book, so I added her image. She's pretty, but already married this. So. Okay. We also have some kind of we can control. Sorry. We can control that. We can make a lookup table, and we can change the parameters, so we can make some kind of this kind of metallic image is possible. Blending function in OpenVG there is 10 blending function. The normal ported up the blending equation is in, and then additionally the darken, lighten, multiply, screen, and additive. The additive blending is included. So, in case of image drawing, I like to say that there is 3 kinds of drawing mode. So, that 3 mode is the influence to blending mode. So, it's possible to such kind of blending image is possible. So, this is a list of all the 30 images. You can. It is very hard to understand intuitively, but yeah, you should study. But in case of implementing SVG or flashlight player, actually they just use a source of blending, portrait of blending. So you don't have to learn that. If you want some special effect or special screening effect, then you should learn this blending effect. Okay. In just before the image is drawn into screen, we can do color transform. Color transform is we can control some RGB by just multiply scale factor and plus we can add or subtract the bias factor. Then we can achieve that. This image is original image, and we can make it more bright image or more dark image, or sometimes it is possible to inverse color image is possible. Font. In OpenVG 1.1 version, we have a font drawing function, but it is not possible to draw. If we give some string, then the OpenVG engine rendering into the bitmap the character. That kind of feature is not included in OpenVG. So the OpenVG's font function is for developing font system. So if you have planned to developing open type or true type font renderer or something, then you need to run this feature. But normally it is not used in the OpenVG development. Many companies, the font vendors, has OpenVG interface, so you can, if you license that product, and you can use how to accelerate font system. Okay, I will explain that how to implement OpenVG. The number one way is the hardware implementation. So you see that the Takumi's demo, so it has a really high performance and high quality rendering. Second way is we can implement with software. Of course, the OpenVG API is designed for we assume that the hardware acceleration, but it is possible to use in low performance case. For example, we don't have to, in case of drawing the navigation system in car display, we don't have to draw map in every map 60 frames per second. No one see that so dynamic map drawing. So the one frame per second is enough to that kind of application. In that case, we can use the OpenVG software. And then another way is the OpenVG rendering on OpenGL hardware. There's 2 kinds of things using Stensible or not, but we need tessellation function because OpenVG input polygon can be very complex polygon, or the self-intersect complex polygon is possible. So we should we should change into all geometry into triangle because OpenGL only support rendering of a triangle. So, but in case of very complex shape, and if it is changed shape in every frame, it means that we should do tessellate in every frame. Sometimes it makes much more slower than soft rendering. So we should use this feature carefully. However, in case of drawing the fixed shape like a map or something, just one-time tessellation can be used again and again in drawing every frame. So in that case, this implementation is very useful, but in shape-changing operation like a mopping or something, then it sometimes it makes a really bad performance. Okay. And another way of the OpenVG implementation is the accelerating using the bitmap graphics. There are so many bitplate hardware accelerator or bitmap graphics engines. So, in our experience, we concluded that even though that very complex vector graphics rendering, the 80% of that rendering is bitmap graphics, blending or something, image transformation or something. So if we have very fast bitmap graphics, we can achieve more than 4 times faster rendering engine. So we can use the multimedia hardware bitmap graphics engine to rendering OpenVG. This is very important diagram that what various kind of graphics API related to OpenVG. OpenVG is designed for SVG Tiny, so naturally JSR 226, 287, and 271 can be accelerated on SVG hardware or OpenVG hardware. And then the MPEG has some rich media standard. The MPEG Part 20, its nickname is Laser. Laser has 2 components, MPEG and SVG. So MPEG is related to OpenVG. And the Open Mobile Alliance which define the multimedia mobile service. So they have various kind of standard like DCD. DCD is push service, and MMS is. Many people think that MMS only has the photo or movie sending, but they also have the vector graphics feature. That vector graphics feature is SVG, and what browser should have SVG viewer. And in HTML5 canvas 2D element should be it is OpenVG is best way to implement canvas 2D because you can see the spec of a canvas 2D, which is now developing that spec, but you surely see that there is the direct one-to-one mapping between OpenVG and canvas 2D. So it means that if we use OpenVG, that canvas 2D is canvas 2D implementation is very easy on OpenVG. Some applications use WebKit, source code, and GTK and Cairo middleware. You implemented on OpenVG, but the problem is some Cairo and GTK plus implementation just use the blending function only. They are not fully implemented on OpenVG. The path drawing and image drawing, they don't use it. They render image by software, and the result image is blending using OpenVG hardware. So very limited thing is implemented. I mean, if you download the source code of GTK Plus, then you can see that the partially implemented on OpenVG, but there is a fully OpenVG implemented the WebKit is used, but I think it is used in BlackBerry. So I think the private company owned that technology, so you can download the source code of that. And the proprietary technology like BlackBerry JDE and Nokia Qt and Adobe Flash Player can be accelerated on OpenVG, and Google Skia trying to use the OpenGL hardware. And in case of it is a very delicate problem. Although Flash Player, in case of light version, they can be accelerated on OpenVG, but in version 10.1 and 10.2 or later, they can be accelerated on OpenGL. Yes. So two track of acceleration, so it makes some problem. And I'll talk later, but we try, OpenVG working group trying to making the OpenVG light profile. So some company already has some OpenVG implementation, but because the OpenVG implementation is not broadened as an OpenGL, yes. So Trevett trying to implement again on OpenGL, yes. So we hope that eliminate the redundant development effort. So if we have OpenVG implementation on OpenGL, yes, then many companies don't have to waste of time or waste of effort. So we are trying to make a new profile. This is because the OpenVG has very sophisticated feature, so that feature is not possible to implement it on OpenGL hardware. So they're trying to making new profile to supporting this kind of Qt or BlackBerry or the PlaySide player and SVG can be implementable on OpenVG like profile. I'll show some example of applications. The GUI, the somewhat older dated, but many Samsung GUI is developed with OpenVG. Currently, low price Samsung's all low price cellular phone GUI is drawn with OpenVG, and high price device use Android or other platforms. So other platform and low all feature phones use OpenVG to draw their GUI, and Nokia has very special devices. That in case of Nokia 500, they don't have OpenGL hardware, but they have OpenVG accelerating hardware. So Nokia trying to draw all GUI. The Nokia's GUI platform is Qt, and Qt is based on OpenVG. So Nokia's GUI accelerated on OpenVG, and I show in my demo they are showing the ebook for SVG. I mean, the rich media service can be accelerated with OpenVG. Okay. And also, in case of drawing very precise rendering over the gauge or something, the OpenVG is good tool for drawing this kind of gauge. Okay, this is OpenVG roadmap. We are trying. I already said that we are trying to make an OpenVG light profile. We hope that as soon as possible we release this OpenVG light profile spec, and then we hope that some source code will be opened by my company, and we will open the study kit of OpenVG 1.1 and OpenVG Lite very soon, and then we can maybe sooner or later you can download it from the Khronos Kite site of the Khronos Institute of Training and Education, and then we will release sample codes and the PowerPoint file to have the study and training. That's all of my talk. Any question about English? Thank you.